Hello friends, today we are going to start with the MCQ questions which were asked in the last 4 GPSC exams conducted for different recruitments of Food and Drug Administration. So for in this lecture we will first discuss the questions which were asked in the exams, the answers of that questions, and then we will study few topics which are surrounding these questions. So first question which was asked is, posology is a branch of pharmacy which deals with. Now this question was asked twice. One more question will come later. So posology, as you know that the posology is the study of doses. What dose is to be given on the basis of the age or body weight or surface area. So there are 4 options over here: study of dosage forms, study of doses, study of drug interaction, and all of the above. The correct answer is study of doses. Here we are studying the dose provided to the children's based on the age or body weight or body surface area. Next question which was asked in one of the exam is, we need to translate omni nocte into English. The options are draughts 1 tablespoonful every night and whenever necessary. In Latin, omni means every and nocte means night. So correct answer is every night. Then urethral suppositories are also called as. There are 4 options: pessaries, nasal bogies, and none of the above. So the pessaries are for vaginal suppositories. Nasal bogies are which are given in nasal cavity. So the correct answer is bogies only. Then how many fluid ounces are in a pint? There are different units used for measurement of the capacity, ranging from gallon, then pint, quart, etc. Okay, so 1 pint, that is equivalent to 20 fluid ounce. 1 gallon, that is equivalent to 160 fluid ounce. 1 pint, that is equivalent to 20 fluid ounce. That is half of the quart. Next, choose the correct formula of Young's formula for the calculation of the child dose. This is also a question related to posology. So there are different formulas given. The last one is Young's formula. Okay, that is age in years divided by age in years plus 12 into adult dose. In India, dash volume of alcohol is considered to be equal to 100 volumes of proof spirit. Now in India we follow the British system, and over here we are using proof spirit, that is 57.1. These are the options given. Out of this, 57.1 is the correct answer. Later on we will also go with some calculations how to calculate the proof spirit of different concentrations of alcohol provided. Next, which of the following is or are the type of physical incompatibility? Though this is a question related to incompatibility, but I have taken over here as it is somewhat related to this topic. So physical incompatibility is the physical change, anything which we can visually observe and it is merely physical. Normally no chemical reaction is required. So the options are immiscibility, insolubility, precipitation, and all of the above. So the correct answer is all of the above. Immiscibility, here 2 or more liquids which we are using, or a solid and a liquid which we are using, they are immiscible with each other. That is why it is physically incompatible. Insolubility, a solid is insoluble in a liquid, and that is a physical incompatibility. Precipitation, now here sometimes there may be confusion. The precipitation sometimes occurs due to chemical change. At that time it is a part of chemical incompatibility, but sometimes this precipitation may be observed because of the physical change, that is because of the addition of anti-solvent. Normally there is no change in the structure of the chemical component or active ingredient present, but still there is precipitation. So at that time when we are changing the solvent and the precipitation is observed, that kind of precipitation is a part of physical incompatibility. So the correct answer is all of the above. Next one is a metric equivalent volume value of 1 dessert spoonful is. Now, in uh, imperial system, household measures are sometimes prescribed. You need to take 1 teaspoonful, 1 tablespoonful, 1 dessert spoonful, etc., etc. So, 1 dessert spoonful. Dessert is what we take after food. Normally, we consume ice cream. So, the volume of the ice cream scoop, which you normally have observed, is around 8 ml. So, the correct answer is 8 ml. Okay. Next is posology is a branch of pharmacy which deals with, the same question is repeated in another exam as well, the study of doses. So with this questions, let us start with the pharmaceutical calculations. There are possibilities that other questions may also be asked from the same topic which are related to the previous questions, and that is why we will briefly go through the different pharmaceutical calculations. So first, there are two types of systems of weight and measures. First one is the imperial system and second one is the metric system. The imperial system was previously used before a few years. The pharmacists used to dispense the medicines. They compounded the medicine at their place and dispensed it, and hence the prescription which were given by the doctors, the medical practitioners, were in Latin, and that is why we are going to study these calculations. So this imperial system was used at that time. Nowadays we are having ready-made dosage forms available on the shelf of pharmacists, and just pharmacists need to dispense it, and hence majority of the doses nowadays are in metric system. So the imperial system is divided in two types, two parts. For the purpose of measurement of weight, mind well, for measurement of capacity there is only one system, and that is uniform system. While for the measurement of weight there are two systems available. First is the avoirdupois system and second is the apothecaries system. We normally utilize apothecaries system for majority of the calculations. Now the avoirdupois system, over here the pound is the standard unit of the weight, and all measures of mass are derived from the standard pound. So 1 pound is considered as equivalent to 16 ounce, that is avoirdupois ounce. Then 1 pound, that is equivalent to 7000 grains, and 1 ounce avoirdupois, that is equivalent to 7000 divided by 16, that is 437.5 grains. So over here pound is the basic unit. In apothecary system, in apothecary system, the apothecary system is also known as Troy system. Over here grain is the standard unit, basic unit, and all weights and other units are derived from it. So 20 grains, grains is the smallest unit, 20 grains, that is equivalent to 1 scruple. 60 grains are equivalent to 1 dram. Sometimes some people pronounce this as drachm or drachm, but normally the correct pronunciation is dram. Then 480 grains are equivalent to 1 ounce, apothecary ounce, and 8 drams are equivalent to 1 apothecary ounce. These interconversions are also sometimes asked in some exams. 12 ounce are equivalent to 1 pound, and 5760 grains, they are equivalent to 1 pound. Then measures of capacity. So measures of capacity are same in both the systems, and gallon is considered as a standard unit for all other measurements of the capacity, and all other capacity are derived from the gallon. So 1 gallon, which is given the symbol C, that is equivalent to 160 fluid ounce. 1 gallon, that is equivalent to 160 fluid ounce. 1/4 of a gallon, that is called 1 quart. We are using the word quarter. Okay, quarter is the fourth part. So 1/4 of the gallon is considered as a 1 quart. 1/8 of a gallon, that is half the quarter, that is known as pint, and pint is normally denoted by O or phi. Sometimes we are writing phi. Okay, the symbol like this. This is also a symbol of pint. sometimes only 5 or 0. Oh, 1 by 1/60th part of a gallon, that is a fluid ounce. So it is similar, vice versa. Okay, 1 gallon is equal to 160 fluid ounce, and opposite to that, 1/8 of a fluid ounce is 1 fluid dram. In capacity of the weight also the same applies. 8 drams are equivalent to 1 ounce. When it is a capacity, the fluid is placed in front of it. So fluid ounce, fluid dram. Then 1/60th, 1 divided by 60, that is 60th part of a fluid dram, that is 1 minim. As in case of weight, it is grain. Over here the smallest unit is minims, and 1 fluid dram, that is equivalent to 60 minims. 1 fluid dram, that is equivalent to 60 minims. Similarly, 1 quart, that is equivalent to 40 fluid ounce, as studied over here. Then 1 pint, that is equivalent to 12 ounce, as discussed over here. And 1 fluid ounce, that is equivalent to 480 minims, because 1 fluid ounce, that is equivalent to 8 drams, and 1 fluid dram, that is equivalent to 60 minims. So 60 multiplied by 8, it comes to 480. So 1 fluid ounce, that is equivalent to 480 minims. Then the metric system. The metric system is the system which we are using at present, and over here all the weights and measures are in the multiple of 10. So that is, their values can be increased or decreased by placing a specific suffix before the unit, and the suffix normally having a value in the multiple of 10. So kilogram is standard unit for measurement of weight, and all other measures are derived from it. The liter is a standard unit for capacity, and 1 liter, that is equivalent to 1000 milliliter. 1 kilogram, that is equivalent to 1000 gram. 1 kilogram, that is equivalent to 1000 gram. K means 1000, as you know. Then hecto, that is 100. H means 100. Then deca, DA, that is 10. So there is a one trick for that, remembering for that. T, G, M, K, H, DA. Okay, these are the larger units. This is 10 raised to 6, 10 raised to 3, my mistake, 10 raised to 9, 10 raised to 6, 10 raised to 3, still my mistake, 1 minute, starting from lower, let us start with lower. Deca means 10, hecta means 100, that is 10 raised to 1, 10 raised to 2, 10 raised to 3, 10 raised to 6, 10 raised to 9, and 10 raised to 12. 10 raised to 3, 6, 9, and 12. 10 raised to x. Okay, I am writing over here. So when the suffix deca is there, it implies that the unit needs to be multiplied with 10. Hecta, that is multiplied by 100. Kilo, that is multiplied by 1000, 10 raised to 3. Mega, 10 raised to 6. Giga, 10 raised to 9, and tera, 10 raised to 12. So T, G, Makhada. For remembering this, the trick is T, G, Makhada. Similarly, for smaller units, it is D, small d, C, mu, N, P, F and A. This is till smallest ones. So D means 10 raised to minus 1. C means 10 raised to minus 2. M, by mistake over here M is remaining. M means 10 raised to minus 3. Mu means 10 raised to minus 6. Then N 10 raised to minus 9. P means 10 raised to minus 12. F 10 raised to minus 15. And A means 10 raised to minus 18. Okay. D, C, Munaffa, M, U, N, P, F, A. D means deci, C means centi, M means milli, mu means micro, N means nano, P means pico, F means femto, and A means atto. So you place a prefix PM that indicates picometers for the measurement of length. You put the PL, that is picoliters, that is 10 raised to minus 12 liters. Okay, 10 raised to minus 12 liters. Similarly, nanometer, that is 10 raised to minus 9 meters. Milliliter, that is 10 raised to minus 3 liters, and so on. So using this TG Makda, DC Munaffa, you can easily remember it. TG Makda, DC Munaffa. That will be helpful for remembering the system. Okay. Then the conversion tables for between the imperial system and metric system. Sometimes the prescriptions are given in the imperial system and we need to convert them to the metric system. So at that time we need to know the relationship between these two. So 1 kilogram, that is equivalent to 2.2 pounds. 30 grams is considered as equivalent to 1 ounce. For 50 grams, that is equivalent to 1 pound. 1 gram, that is equivalent to about 15 grains, and 60 milligrams, that is equivalent to approximately 1 grain. Now if we convert this, try to convert this in between each other, sometimes there are chances of difference. Okay, so when there are small units, we need to start with the smaller calculations. When there are larger units given, we need to start with the larger conversion. Okay, if we start with the smaller conversions for larger units, then there are chances of differences. For an example, if I consider that 16 milligrams, that is 1 grain, and I know that 1 ounce, that is 8 fluid drams, and that is equivalent to 480 grains. Okay, if I multiply this 480 with 60, the answer will not come to 30 grams. So there will be a difference. So in such cases we need to take some liberty. When smaller units are there, we need to start with the smaller units. When larger units are there, we need to start with the larger units. Similarly, for capacity also the same thing applies. So the capacity 1000 ml, that is equivalent to 1 quart. 1 quart is 1 by 4 gallons. Okay, and that is equivalent to 40 fluid ounce. Now as we know that we are converting 30 ml as 1 fluid ounce. So if we multiply 30 by 40, it comes to 1200 ml, but over here we are taking as 1000 ml, that is 1 liter. So here also we are taking some liberty. So whenever there are larger volumes or larger weights, we need to start with the larger ones. Whenever there are smaller, we take with the smaller ones, and such kind of differences are allowed. So 500 ml, that is equivalent to 1 pint. 1 pint is the half quarter or 1/8 part of a gallon, that is equivalent to 20 fluid ounce. 30 ml, that is equivalent to 1 fluid ounce. 4 ml, that is equivalent to 1 fluid dram. If we consider this also, there is a difference, because 1 fluid ounce, that is containing 8 fluid drams, and when we multiply 8 with 4, it comes to 32, but we are taking over here as a 30. So we need to consider this kind of differences, we need to accept them. Then 1 ml, that is equivalent to 15 minims, and 0.06 ml, that is considered as a 1 minim. In other words, the minim is nearly equivalent to 1 drop. Sometimes for pediatrics or infants, what we can say, the dose is prescribed in drops. That is, you need to give 1 drop or 2 drop or 5 drops or 7 drops of the product or preparation to the infants or very young child. So 1 drop is equivalent to 0.06 ml. Now conversion table for domestic measures, household measures. Now as we have discussed previously, one question was asked about 1 dessert spoonful. Its metric equivalence was asked. Okay, so metric equivalent is 8 ml. If its imperial equivalent has been asked, then it comes to 2 fluid drams. Okay, and as we discussed, 1 drop, that is equivalent to 1 minim or 0.06 ml. 1 teaspoonful, that is equivalent to 4 ml or 1 fluid dram. 1 tablespoonful, the spoon which we are taking at our table for taking the food, okay, that is equivalent to 15 ml or 4 fluid drams. 2 tablespoonful, that is equivalent to 1 fluid ounce or 30 ml. 1 wine glassful, that is equivalent to 60 ml or 2 fluid ounce. 1 tea cup full, that is 120 ml or 4 fluid ounce, and 1 tumbler full, that is equivalent to 8 fluid ounce or 240 ml. So these are the domestic or household measures. They are also known as household measure or domestic measures. And majority of the doctors or prescribers are also prescribed that you need to take 1 teaspoonful or 2 teaspoonful, the older practitioners. Nowadays the formulations are available with the calibrated caps, and that is why the patient can easily take a desired volume. Now percentage calculations. So there are 4 types of percentage calculations possible: percentage weight by weight, percentage volume by volume, percentage weight by volume, and percentage volume by weight. In majority of the cases, we either use percentage weight by weight or percentage volume by volume. So in majority of the cases our work is done with this. In few cases, when we are having solid mixtures, we go for percentage weight by weight as well, but percentage volume by weight is very rarely used. It is used only when we adsorb a liquid on the surface of a solid. At that time we will go for percentage volume by weight, but normally it is not used. Now in the metric system, it is easy to calculate the percentage weight by volume calculations, but when we move to imperial system, it becomes somewhat difficult. So let us discuss the formula. How can we calculate percentage weight by volume in imperial system? In metric system, we know that we dissolve 1 gram of any solid in 100 ml. It gives 1% weight by volume. Okay, in metric system, it gives 1% weight by volume. But when we take the imperial system, it is not such equivalent, and that is why 3 different formulas are suggested. Formula A, it says that 1 grain solid, when it dissolved in solvent to produce 110 minims. 110 minims. Remember, in metric system it is 100 ml. Over here it is 110 minims. At that time it produces 1% weight by volume solution. Then formula B says that when solid is 4.375 grains and solvent to produce 1 fluid ounce, it gives 1% weight by volume solution. And solid 35 grains dissolved in a solvent to produce 8 fluid ounce, we get 1% weight by volume solution. Now which formula is to be used at what place? That you need to remember. So when your solution is very dilute and volume of the solution is also small, at that time we can use formula A. When the solution is very concentrated or volume is very high, at that time we can use this formula C. When the solution is dilute and volume is medium, intermediate, or the solution is concentrated and volume is low, at that time we can use the formula C. So in intermediate conditions we can use the formula C. Otherwise, in smaller volumes or smaller concentrations, formula A, higher volume and higher concentration, formula C. Results obtained by calculating different formula will be different. Mind well, the results obtained by using different formula will be different. There will be some difference if we calculate using formula A and using formula B. So when the small volume is there and dilute solution is there, we prefer formula A. Now the preparation of percentage solutions by diluting the concentrated solution. Sometimes we are having we are not having solids as such, but we are having a concentrated solution and we need to dilute that concentrated solution to produce a dilute solution. So for an example, HCl, hydrochloric acid solution. So concentrated HCl is available in market. As you know that hydrochloric acid is a gas and it is dissolved in a liquid. So hydrochloric acid is available in the market in the form of solution only, and we need to prepare dilute HCl from a concentrated HCl. So in such cases we can use these formulas. So strength of dilute solution is equivalent to strength of concentrate divided by degree of dilutions. Say we want to prepare 5% solution from 50% solution. Okay, so we need to dilute it 10 times. So degree of dilution over here will be 10. Or sometimes it has been asked that a 50% solution is there and it is diluted 5 times. The resultant concentration will be 10%. Clear? So using this we can find out what degree of dilution is required or what will be the resultant solution when a given solution is diluted. Then volume of stronger solution or of alcohol to be used, that is volume required multiplied by percentage required divided by percentage used. It is similar to the equation which we already studied, M1V1 is equal to M2V2. Okay, it is similar to this equation. So by using this equation also you can find out. Over here weight of stronger acid to be used, that is weight required multiplied by percentage required divided by percentage used. So using these three equations we can find out the volume or weight of concentrated solution required to prepare a dilute solution or degree of dilution required to prepare a dilute solution from a concentrated solution. Now understanding parts per parts. Sometimes the concentrations are represented as parts per parts, that is 1 in 100. It is simply 1%. Okay. Sometimes different values are given, that is 1 in 2000. So in such cases we need to find out the concentration of this 1 in 2000 solution. So the simplest trick to find out this is divide 100 by the number given 1 in 2000. So 100 divided by 2000. Whatever answer is there, it is the percentage concentration. Clear? So we cross out this, it comes to 0.05. Clear? So this is your strength in percentage. Sometimes the parts are given, that is 4 in 5000. So in such cases, the same formula can be used with a little modification. You need to place the parts given 4 into 1000 divided by 5000, and your answer will be there. So in such cases, you need to take care that you are not making any mistake in transferring the decimals. The common mistake which is normally observed is passing the decimals, and because of the incorrect placement of the decimals, the entire answer becomes incorrect. So while placing the decimal, utmost care is to be taken. Clear? So simplest, the generalized formula I can write over here, that is parts given. Okay, parts given into 100 divided by volume. How much volume is there in which this many parts are present? So parts multiplied by 100 divided by final volume, that will give you the percentage. So the parts per parts are calculated using like this. Now posology. As we know that there are 3 questions asked in last 4 exams related to the Food and Drug Administration. Let us discuss with the posology. There are different formulas. First formula, first category of the formulas is proportionate to age. So there are different formulas for that. First one is the Young's formula. Young's formula says that dose of a child, that is equivalent to age in years divided by age plus 12 multiplied by adult dose. Now sometimes this mistake is also observed during calculation. The adult dose is not placed, and sometimes as per a normal or usual habit, we multiply it by 100. So we need to take care that what dose has been given in the question and not the 100. Okay, for normally percentage calculation we place 100. So over here there is a common mistake that 100 is placed by mistake. So we need to take care. Now the above formula is used the calculation of dose for children under the age of 12 years. Mind well, when it is not specified in exam that which formula is to be used, we need to use this formula only if the age of the child is under 12 years. For the child above 12 years, next formula will be applicable. Okay, next formula is Dilling's formula. In Dilling's formula, it says that dose for a child is equal to age in years divided by 20. So you need to directly place the age over here and divide it by 20. So this formula can be used for calculating the dose for the child above 12 years of age. Young's formula is applicable for less than 12 years. This can be used for child above 10 years as well. Then Freud's formula. Freud's formula says the dose of child is equal to age in months. Over here the age is in months divided by 150 multiplied by adult dose. So here the age is provided in months, and this formula is normally used for infants. The child which are having age less than 2 years, we will prefer this formula. Next is proportionate to body weight. So dose of child, that is equivalent to weight of the body weight. So weight of the child divided by 150. Here weight which is used is in pounds, mind well, lb, and not in kilograms. The adult weight is considered as 150 pounds. 150 pounds is equivalent to 150 divided by 2.2. Okay, 150 divided by 2.2. 2.2 is the conversion factor for pounds to kilograms. So average adult weight is considered as around 75 kg, and using that, my mistake, 670 kg, around 70 kg, and that is why the dose is calculated using this formula. So over here the weight of the child should be taken in pounds. So So during exam also, if it is been asked and weight is given in the kilograms, you need to first convert it to the pounds and then you need to use this formula. Next is proportionate to body surface area. So dose of child is equivalent to surface area of the child divided by surface area of adult multiplied by adult dose. Now practically it is very difficult to determine the surface area, and that is why this formula is very rarely used. But though if surface area is given for the theoretical purpose, we can use this formula. The adult body surface area is considered as 1.73 meters square, and hence the equation can be corrected as dose for a child is equal to surface area of the child divided by 1.73 meter square into adult dose. The body surface area is required in meter square. Now isotonic solutions. There are sometimes the questions asked about the isotonicity, and we know that the solutions which are hypertonic or hypotonic, they may affect the body, like for IV injections they may affect the RBCs. For ophthalmic preparations they affect the eye, because if they are paratonic then they may irritate, and that is why they may increase the lacrimal secretion and thereby reduce the residential time of a dosage form, and that is why they must be isotonic. Now isotonicity is adjusted based on the freezing point method. First method, over here the percentage weight by volume of adjusting substance required is equal to 0.52 minus A divided by B, where A is the freezing point depression of the unadjusted solution and B is the freezing point of 1% weight by volume solution of adjusting substance. 0.52 actually is the freezing point depression of 0.9% weight by volume sodium chloride solution or our blood, both, and this is why we considered 0.9% weight by volume sodium chloride as isotonic solution. 0.9% weight by volume sodium chloride as isotonic solution. So 0.52, actually 1% solution of sodium chloride can be used, the freezing point depression of 1% sodium chloride solution is provided in the literature. So it is minus 0.57, okay, and that is why 0.9% sodium chloride solution will depress the freezing point of water by 0.52 degree centigrade, 0.52 degree centigrade, and that implies that the freezing point of 0.9% sodium chloride solution will be minus 0.52 degree centigrade. So most commonly we are using sodium chloride as an adjusting substance, and that is why you need to remember the freezing point depression of sodium chloride 1%, that is 0.57. A is the freezing point depression of the given solution or given solute, and that is normally given. Next is based on molecular weight concentration. There is a simple formula: percentage weight by volume of adjusting substance is equal to 0.03 multiplied by m divided by n, where m is the gram molecular weight of the adjusting substance. It's a molecular weight of adjusting substance, and n is the number of ions into which the substance is ionized. For an example, if we are using sodium chloride as an adjusting substance, it will ionize to two ions, Na plus and Cl minus. So over here N is equal to 2 for sodium chloride. If we use dextrose as a adjusting substance, mind well, if we are using dextrose as an adjusting substance, it will not dissociate in the body, it will not ionize in the blood or water, and that is why N is equal to 1 for dextrose. So how many ions are provided by the substance, that is called N value, and M is the molecular weight of the adjusting substance. So using this formula also we can find out the isotonic solution, what concentration will be isotonic. Next is alligation method. Sometimes we are provided with a concentrated solutions, and two concentrated or one concentrated and one dilute solution is there, and we have to prepare another concentration which is in between these two provided concentrations. At such uh, instances we can use alligation method. So it involves the mixing of two similar preparations of different strength to produce a preparations of intermediate strength. For calculation purpose, here the data are organized like this. You can write in both the ways, stronger solution and weaker solution over here. Sometimes in some books you may find that stronger solution is placed here, weaker solution is placed over here, and the required concentration is placed over here. This is also true, this method is also true. Now we need to take the difference between stronger and required, and we need to write over here. Difference of weaker and required is to be written over here. So say this is the value A and this is the value B. That is, A parts of the stronger solution and B parts of the weaker solution, when they are mixed together, they will produce the solution with the concentration R, that is required. I am repeating, when A parts of the stronger solution and B parts of the weaker solution mixed together, it will produce the solution with the required strength. Now these concentrations are in, these portions are in parts, so we need to calculate it into volume. So how to calculate it? Let us understand it with few examples. Okay, so we will go with one or two examples so that we can understand it easily. So here one example is there. Calculate the volume of 95% alcohol required to prepare 600 ml of 70% alcohol. Now over here the higher concentration is 95% and no lower concentration is provided. That means we have to use water as a diluting medium. So water is considered as 0% of anything. Whenever water is used, it is considered as a 0%. So higher strength is placed over here, lower strength is placed over here, and the required strength is placed over here. The difference between the higher and required is 25. The difference between lower and the required is 70. My mistake over here, there is a mistake, 70. So the 70 parts of 95% alcohol and 25 parts of water, when mixed together, it produces 70% alcohol. Now it will produce 95 parts, 70 parts plus 25 parts. We require 600 ml. So if we mix 70 ml and 25 ml, it provides 95 ml. So for preparing 600 ml, we need to calculate accordingly. So let us discuss how. So 70 parts of 95% alcohol and 25 parts of water will produce 70% alcohol. So quantity of 95% alcohol required will be 70 multiplied by 600 divided by 95, because the total of 70 plus 25 comes to 95. So if we want 95 ml of total solution, we need to take 70 ml. Okay, we can calculate this by placing the data like this. If we want to prepare 95 ml, we require 70 ml of the 95%. We require 600 ml. So cross multiplication, 670 multiplied by 600 divided by 95. So cross multiplication is known to you. Using this cross multiplication, we can easily find out the volume, and the remaining volume is to be made up with the water. So we can directly subtract this value from the total volume required, or we can use the same formula, cross multiplication, and we can find out the quantity of water required. So by this we can find out the volume of both the portions required to prepare the required concentration with required volume. We can check this as well, whether the calculations are correct or not. So later on we will discuss whether our checking is correct or not. Here this is multiple alligation. When we have a mixture of more than two different solutions and we want to prepare an intermediate solution, at that time we can write all the portions in a descending order of the concentrations. Over here we can use 70, 60, 40 and 30% alcohol to produce 50% alcohol. So we need to write them in descending order, and we need to place this required at a place where it comes in between. It comes between 60 and 40, so we need to place over here. Now difference between 70 and 50, 20, 60 and 50, 10, 40 and 50, 10, and 30 and 50, 20. So 20 parts of 70%, 10 parts of 60%, 10 parts of 40% and 20 parts of 30%. When they are mixed together, they will provide 50% alcohol. Now over here total parts produced will be 60. Here no volume is specified over here, that is why total 60 ml will be produced if we mix 20 ml 70%, 10 ml 60%, 10 ml 40% and 20 ml 30%. Let us check whether the calculations are correct or not. So for checking, let me explain how we can check it. So we can check by multiplying 70 multiplied by 20 plus 60 multiplied by 10. 70% 20 parts, 60% 10 parts, plus 40% 10 parts, plus 30% 20 parts. Total parts produced will be 3000. For prepared solution, the strength is 50 and the parts produced are 20 plus 10 plus 10 plus 20. So 60 multiplied by 50, that comes to 3000. So if both are equal, we can say that the calculation is correct. Okay, so by this we can check whether the calculation is correct or not. Let us go through one more example. Calculate the amount of 90, 60, 30% alcohol and water required to produce 500 ml of 50%. Over here the volume is also provided. So we need to write all the concentrations in the descending order. Place 50 at the central part. Difference between 90 and 50, that is 40, 60 and 50, that is 10, 30 and 50, that is 20, and 0 and 50, that is 50 parts. So 50 parts of 90%, 20 parts of 60%, 10 parts of 30% and 40 parts of water will produce 120 parts. Now this calculation is for 120. We want to prepare 500. So volume of 90% alcohol required will be 50 multiplied by 500 divided by 120, because 50 parts are required. Similarly we can calculate for others as well, and we can subtract all the required concentrations from final volume, so we can get the volume of water required. Next is proof spirit. As one question was asked for proof spirit as well, we will discuss what is proof spirit and how to calculate the proof strength of provided alcohol. So proof spirit, so for exercise purpose, the strength of alcoholic preparations are normally indicated by degrees, overproof or underproof, because alcohols in India and many other countries comes under excise, and the tax is collected on the basis of the proofs of alcohol present, not on the basis of volume of final alcohol. So tax is only collected on the basis of proofs of alcohol present, percentage of alcohol present, and that is why the alcohol is considered either underproof or overproof. So proof spirit is that mixture of alcohol and water that at 51 degree Fahrenheit weighs 12/13 of equal volume of water. Now as you know that water is having specific gravity of 1 at normal conditions, and alcohol is having specific gravity less than 1. So when we mix alcohol and water, the specific gravity of this mixture decreases. So as the concentration of alcohol increases, the specific gravity decreases. So the specific gravity equivalent to 12 divided by 13 is provided by a specific concentration of alcohol, and that concentration is 57.1% volume by volume, and that is considered as 100 proof. That is considered as 100 proof or 100 volumes of proof spirit. Now let us discuss how to calculate this proof spirit. 100 proof is 57.1. So the concentration above 57.1 is considered as overproof, and concentration below 57.1 is considered as a underproof. So any strength of alcohol can be converted to proof strength and vice versa by using the following method. First one is multiply the percentage strength of alcohol by 1.75 and deduct 100 from that product. If the result is positive, it is overproof. If the result is negative, it is underproof. We are not changing anything in the values. We are only writing underproof and overproof. So we need to multiply the given concentration with 1.75. Now how this 1.75 is answer? So if you divide 100 by 57.1, the answer comes to 1.75 nearly. So that is 1.75. Okay, 57 point. If you divide 100 by 57.1, the answer comes to 1.75. Let us understand it with an example. Find out the strength of 95% volume by volume alcohol in terms of proof spirit. So volume given is 95. So by applying the formula, 95 multiplied by 1.75 minus 100. So 166.25 minus 100. Here the answer is 66.25 and it is positive. So it is labeled as OP, that is overproof. If it is negative, we need to write as UP or underproof. Let us go through another example. Calculate the real strength of 30 degree OP and 40 degree OP. Here there are two solutions given. 30 OP means 30 plus 100, 130. So alcohol strength is equal to 130 divided by 1.75. It comes to 74.28%. And 40 UP means 100 minus 40. So 60. So alcohol strength is equal to 60 divided by 1.75, that is 34.28. We can check it by again using the formula. This 74.28 multiplied by 1.75 minus 100, 129.99 minus 100, that is nearly equivalent to 30. Similarly for second one, 34.28 multiplied by 1.75 minus 100, that is equivalent to 60 minus 100, that comes to minus 40. And as it is minus 40, we consider 40 underproof. So by this we can calculate the proof strength of the alcohol. With this we are ending our today's lecture. Thank you very much. Hope we will meet again with another lecture.